Today I will talk about this potential difference and electromotive force. Now these two terms are very confusing for students. Today I want to promise that you'll understand these two terms very clearly and you'll be able to explain this to your friend also. And you can differentiate these two terms also. But before starting potential difference and electromotive force, we must have a little idea about electric charge. All of we know that electrons have negative charge, protons have positive charge, and the flow of current in a conductor is actually the flow of electron. And if 6.25 into 10 to the power 18 electrons are flowing in this conductor, then we can say that the flow of charge is 1 coulomb. I mean to say, if this much electron crosses the cross section of a conductor, then in 1 second, then we'll say that the flow of current is 1 ampere, but we are not related now with ampere. I'm talking about this number 6.25 into 10 to the power 18 electrons. This is very huge number. It is 6, 2, 5 and 0, 0, 0, 0, 0. If we have 16 0, then this is equivalent with 6.25 into 10 to the power 18 electrons. This is a very huge number. We can say, we can count this as million, billion, trillion, and even after this we cannot count. How much electron? 6.25 into 10 to the power 18 electrons contains 1 coulomb charge. C-O-U-L-O-M-B. This is the unit of charge and this is the symbol for 1 coulomb charge. What I mean to say, first we must know that 1 coulomb charge means the electric charge contained in 6.25 into 10 to the power 18 electrons. And this is negative charge, but we can talk about positive charge also. The same number of proton contains 1 coulomb positive charge, but we are concerned with electric current, and electric current means flow of electron. That's why we are taking electron. Okay, this is 1 coulomb charge. Now I want to talk about now potential difference. Let's say this is a cell and we are connecting this cell with a bulb. Then what happens? The bulb gives light. Why it gives light? Because current is flowing through the conductor and when it reaches to this bulb, when it passes to the bulb, then bulb glows. It means we can say that electrical energy is converting into light energy in this bulb. Now, what is potential difference? The work done between these 2 points of this circuit is called potential difference. It means potential difference can be defined this way. Potential difference is equal to work done by charge. What is the meaning? Potential difference between any 2 points of a circuit is equal to work done by the flow of 1 coulomb charge between those 2 points. That's why if we want to measure the potential difference between these 2 points, then how much work is done between these 2 points by the flow of 1 coulomb charge is being measured. And this is called potential difference and its unit is volt. Now, someone may be confused about this. Work done by the flow of unit charge is called potential difference. How work is done? Force is not applied, distance is not covered. Until and unless we have force and distance, work never be done. And that's why there is another way also to understand this very clearly. How much electrical energy converts into another form of energy between these 2 points when 1 coulomb charge flows from this point to this point, that is called potential difference between these 2 points. It means practically we take one example. If 1 coulomb charge flows from this point to this point, and if 1 joule of electrical energy converts to light energy between these 2 points, then what can we say? The potential difference between these 2 points is 1 volt. It means 1 volt is equal to 1 joule per 1 coulomb charge. When 1 joule of electrical energy converts to light energy or any other form of energy, maybe here we have both, that's why we are talking about light. But how much electrical energy converts between 2 points by the flow of 1 coulomb charge, that represents the potential difference between these 2 points. Energy conversion. This way we can understand better. Now potential difference is understood. Now why we are talking about these 2 points only? Why we are not talking about these 2 points? And we can say that this is conductor, and in a conductor electron flows very easily, and there is no collision of electron with the atoms of this conductor. I mean to say it is negligible. That's why work wouldn't be done between other 2 points of the conductor, but when it passes through the filament of the bulb, then filament has certain obstruction, certain resistance. Because of that resistance, certain amount of electrical energy converts to light energy, because when flowing electron collide with the atoms of the filament, then atom of the filament begins to vibrate, and this vibration makes it white hot and it emits light. It means electrical energy converts to light energy. That's why potential difference is usually measured between 2 points, left hand side point and right hand side point of bulb or maybe any other appliance. Okay, this is the understanding of the potential difference, and conclusion is the energy conversion between 2 points of electrical circuit by the flow of 1 coulomb charge can be understood as what? Can be understood as potential difference between those 2 points. But what is electromotive force? Now it is a little different than potential difference, but both of them have same unit volt. EMF is also measured in volt, PD is also measured in volt, but what is the difference? Difference is when 1 coulomb charge flows from this positive terminal to again the same point, positive terminal, how much energy the cell delivers in the circuit, that represents EMF. The energy delivered by a source for the flow of 1 unit charge throughout the circuit is called what? EMF of that source. It means if this source, this is, let's say, simple cell, if this is simple cell, and from positive point terminal to positive terminal, again we are not talking about positive to negative, positive to positive, or maybe from this point to again the same point throughout the circuit, when 1 coulomb charge is delivered, how much electrical energy it governs with that 1 coulomb charge represents EMF of that source. And if this is simple cell, it delivers 1 joule electrical energy for the flow of 1 coulomb charge around the circuit connected to it. That's why EMF of simple cell is 1 volt. But if the same is not simple cell, it is let's say dry cell, then what happens? It delivers 1.5 joule electrical energy for the flow of 1 coulomb charge around the circuit connected to it. And that's why EMF of a dry cell is 1.5 volt. In the same way, EMF of lead acid cell is 2 volt. That means energy delivered by a source for the flow of 1 unit charge around the circuit means the work done between these 2 points plus the work done inside the cell. Inside the cell, we have certain chemical, and work is done not in this conductor because the obstruction of the flow of current in the conductor is negligible. Work is actually done in this bulb, and work is done inside the cell also, because when electron flows from this negative terminal to positive terminal, or current flows from this negative terminal to positive terminal from inner side, certain amount of obstruction is offered by the chemical also. That's why certain amount of work is also done here. If this is dry cell, the EMF is 1.5 volt. If we measure potential difference between these 2 points by using a voltmeter, maybe the value of potential difference may be 1.3 volt. This is assumed value. Then EMF is 1.5 volt. It means remaining work is done inside the cell by the flow of 1 coulomb charge. That is certainly 0.2 volt. It means internal potential difference and external potential difference. When we add these two, then we will get EMF of the cell. Here, work is done in two different sides. One is inside the cell, another is outside the cell. Total potential difference is equal to EMF. This way, EMF and potential difference can be differentiated. Okay, this was for today.